Let's get started. So I'm Zhihao Yuan. I'm an HPC engineer in simple roles until yesterday. But don't worry, I got a new job next week. So this is going to, I mentioned that my employer, simple roles, deal with lots of matrices, but I didn't say the details. So this talk is about something fun we did with matrices, and hopefully can inspire you about the GUI design. Give me a second. Okay, so how do we understand GUI? In this example, okay, in this example, if you drag this slider stands for row, and this slider stands for the column you want to look at in matrices. And while you are dragging it, the GUI should display the corresponding values of this cell and the corresponding fraction representation of this cell. So how do we understand this? We understand GUI usually as actions and results. The action is dragging, and the result is what we see on screen, the effect of the GUI. So in other words, there is a cause and effect in the GUI. This is the way how we think about it. And that is why we invented the signal, a very popular idea in object-oriented GUI frameworks. But what if there's no action? So maybe I didn't drag the slider. I'm reading some files to get the rows and columns to display. Or maybe I interacted with some other parts of the GUI. So the cause may or may not have something to do with the GUI, but you want GUI to react to it to show some results. Here's an example. It's the same GUI class, cell inspector. Somewhere in the code, I just adjusted the value of one of its data member. How can this to give us a result on the screen? Well, in that case, some people will tell you that is why we need encapsulation. For example, as a trivial example, the fact that a member function called setRow setting a data member to 99 is an implementation detail of setRow 99. And sending a signal can also be an implementation of this function. Frameworks like Qt have something called property binding, which allows you to keep using the syntax I crossed over. But the idea is the same. The nature of thinking is that you should have an interface. Sending a signal is an implementation detail of that interface. But this is not true. Think about this. If sending a signal is an implementation detail of the interface, then no GUI can correctly react to this method expectation, right? Sending a signal becomes a requirement here. And it is equivalent to saying that, the correct way of changing the state of a GUI object is to send a signal. So what happens if changing a state implies sending a signal? That signal becomes the only abstraction. In this example, here is a grid, and it's a multi-selection grid, so that you should be able to select, for example, this 3 cells at the same time, and use a clear button to clear those. Now think about how many signals we need here. If you select this, it's sending a signal to somewhere saying that this is selected. Every cell in this grid needs to send signal when you're doing that. And in the end, if you press clear button, that needs to send signal to everything you selected on the screen. A typical implementation to represent the state I'm showing here is to use a matrices, a Boolean matrices, saying that whether a particular cell is selected or not. If we don't need multi-selection, we don't even need a matrix. A pair of the coordinate is good enough. But in that case, if we are able to represent the states as a matrix, is a single selectable cell still a useful class? If yes, then it should have its own selected states. And you can only use a signal to communicate between. But the cost is that is to have the same number of events. As the time your elements are, the selectable cells are growing, the number of signals you need to send is also growing on the screen. And this thing can become more complicated. For example, how do you model shared states? In this example, obviously, if this link is selected, if link is selected, the volume of both channels should change at the same time, right? In other words, dragging L will send the signal to itself to change its volume, and it should send the signal to change the other channel's volume. Similarly, dragging R should be able to send 2 types of volume, 2 types of signals as well. But if the link is unselected, then they should be only changing the volume of its own channel. Oh, really? Sorry. And that's not only it. What if we add a mute button here? That means if you press mute button, it should send signal to both channels. If this is already muted, and if you manually click somewhere here, that should send a signal to tell you to clear the mute state, right? And also the mute state needs to be associated with link or not linked. So if we use signal as an abstraction, in some cases, we'll find that the number of events grows faster than the number of states. I wouldn't say it's exponential, but it's getting there. So this leaves us a question: what is an abstraction? From a small book called A Philosophy of Software Design, an abstraction is a simplified view of an entity that omits unimportant details. And omitting details that are important leads to obscurity, creating a false abstraction. So if using events as an abstraction that doesn't scale well enough, maybe we can use a different abstraction in GUI. So far, we know that the signal slots event callback model hides state, and states are important. So why don't let users play with their own states? For example, button has a binary state. It is either clicked or not clicked. Then can we do this? A binary state is just a Boolean, right? Well, this is, of course, not legal Qt code, but we can tweak it. So far, it certainly doesn't work because it is checking whether the button is pressed only once. You don't want that behavior. What's the usual way of dealing with this? Pooling. If we are able to run this in a loop, then we can check this again. Of course, the loop runs too fast. Let's add something. We can let the loop run once every 16 milliseconds. And it is pulling for events and asking for processing inputs. And by doing that, we are able to render the whole thing 60 times per second. And that leads us to the basic structure of an ImGUI application. In the main loop, you wait for the windows being closed, pull events process input, finally renders it, and the stuff to render goes into a function for, in this example, update. In other words, we already refactored our GUI code into an update function. The code itself, showing on the screen, is still hypothetical. Look at it. Let's make it more real. So first, we don't need parents of our GUI elements. All GUI elements, so since this is the only function, so far we are calling from the main event loop, right? And we can assume that, and we're re-rendering everything again since the next frame. In other words, all the elements we are creating here are destroyed when this function goes out of scope. So we don't need parents and child to keep track the lifetime of GUI items. We can simply say that all the GUI items are implicitly registered to a items tree, a singleton tree. Next, since we are registering all the items to a items tree, we don't need to name those GUI elements in a program. We can just do this. And next, you may notice that we didn't put any information in the constructor. While in this case, the label is probably the only useful property to set for a button. So why don't we set it in the constructor? Now, then the isClicked becomes roughly the only useful attribute to check. Because we don't need to explicitly give this GUI a name, because it's always registered to the tree, why don't let the function return a Boolean to give the same information? So finally, we are here. That's pure ImGUI. So far, we learned that button returns binary state, and there are, of course, items that returns no state. for example, text. So quick question, what does this update function do? What happens when we replace the print with ImGUI text? The result may be a little bit surprising if it's the first time you touched ImGUI. Do you notice that? The text is flashing at the time you click the button because it's explicit. It's exactly following what you asked it to do. In every frame, you check whether this piece of code, check whether the button is clicked or not. And if it is clicked on that frame, it's displaying a text, which means by default, your update function is stateless. We need to make this stateful. How to do that? This example is, you'll find that this example is too simple. Let's extend our first application a little bit. So let's say the first time you press your next button, it gives you 5 and then 8, 13. So it gives you, it displays a Fibonacci number sequence on the screen, and those should not be flashing. In that case, we are using more bits in our state, so it's a little bit more complicated. So how to make that function stateful? An idea that may be useful here is to turn that function into a closure. Instead of leaving the states local to the update function, we move the states outside function, move the states into this function's closure. And then at the time you press the button, we modify the states. And unconditionally, we display text item in the GUI. The way to use so this is how we used to do with stateless widget. And the way to use a stateful widget would be first you create a closure and then call the closure in the event loop. Here I omitted a detail. You need to call a ImGUI new frame for before drawing anything, but it doesn't fit on screen. So here's a demo of our first application. So how to write this in C++? Does this work? Well, no, because in order to modify a state that is local to the enclosing function, you have to use ref qualifier. And those references will become dangling after this nested function being returned. But of course, closure is not the only way to use ImGUI. There are other ways. And also for C++, you don't necessarily need to use a closure at all. You can use a class and use update member function or just member function operator parentheses. But here's another thought. A widget can also be a generator of frames. So instead of using a closure, we can use coroutines. This is an example of generator in Python. So you can So a generator is a function, a coroutine is a function that can return multiple times. So every time you call, you use yield, it yields the control back to the generator's user. So you can say that here we also have a main loop inside our closure. The main loop for the event loop for using a closure looks like this. And in Python, the event loop for using a frame generator looks like this. You call the next global function, which is a customization point in Python on the closure object. Note that using generators is just a choice. It's not necessarily the right way to model ImGUI. And also, for now, C++ code yield does not generate a void. You always need to generate some value. So far, any questions before I go into the next section? Okay, let's continue and play with those examples. Now it's time to challenge ourselves with this. The usage of this GUI should be, so first, it is a generator of frames. You create a coroutine out of this coroutine function. Here's some data. And called next to start a coroutine. In C++, we would call this initial suspension. And then in the event loop, here I added new frames. I'm going new frame. In the event loop, we send the data. In every frame, we send the data into the coroutine, so that in every frame, it is if we changed this data, the GUI is reacting to new data immediately. That might be why we call this ImGUI immediate mode GUI. So let's start to implement this window. So first, we need to create a window. In ImGUI, a window in code is a region between begin and end. ImGUI implicitly creates a debug window to contain widgets outside the window. We'll say that later. So after we know how to create a window, we need to do so in our generators inner loop. Note that we must receive the data before creating the window, because yield is yielding back its control, right? The function is suspended. If you yield back the control, for example, somewhere here, and in that frame, this function is not called. In other words, you are not finishing a window. You will receive an error if you do it. So the next thing to learn is that how do we use draggers? Here's an example. Drag int with item. It receives a accepted label and the old value before create. Old value maybe you store somewhere, for example, in closure. And min value is smallest value you can drag, max value, largest value you can drag to. And what he returns are first, whether this item has been changed on this frame, and the new value after this frame. In other words, if you have a state somewhere, you should put its O value here, pass it in, and use the second component of the return value to update your state. Let's try to use it. We store the current value somewhere outside the inner loop of the coroutine. Put it in as an old value and update it. Here's a quick demo. You can see that we didn't set the min and max value, so you can drag to negative values. So anyhow, this getting starts to get to work. And then let's go back to the UI itself. Let's decompose the UI. So first we have the begin, which is a window. And then inside the GUI, we have two draggers, which are, I call them index control. And then the part to display, let's call it cell info. Then we can write the generator loop like this. Index control and cell info. The bird's eye view of the entire widget looks like this. The widget is a generator function. It has states. Those are parts. And then in the generator loop, we use those nested functions. To break it down, the first nested function, index control, it should set the min and max value you can drag to the and the shape. You should read the shape of the matrices and limit where you can drag to, and then update your states. This is index control, very simple. And then cell info, we are reading the value out of the matrices at that position. Format its value and format its fraction. Note that in C++20, we also have the stud format. So here's a demo. Now you can know that there's I can no longer drag to negative I and j's. And also, yeah, because my matrix is 200 by 300. So while I'm dragging, those values are updated immediately. And also, what you expect to see on for those floating point formatted results are the same between C++ and Python, because C++ format is also using the shortest round-trippable floating point output. So from this example, we notice that our dragger and two display elements are data binding, right? However, we didn't use any actual data binding. The user can just follow data. In our next example, let's create a widget that with multiple selection. I call this widget selection grid, and the usage like this. Still, it's a generator. You create a generator here, and then initial suspension. What this generator returns, yielding out, should be a list of selected coordinates. For example, If it doesn't select anything, it should yield empty list. If you select several cells, you should yield coordinates. So by doing so, we communicate its states back to its caller. Next question is how to create a widget. Similar to creating a window, but instead of using begin and end, we use begin group and end group. The items in these regions have their horizontal positions locked. So for example, this is a group. If it appears as a window, in a window, it appears like this. But if you are trying to reuse it, create a new text label on its left. If you didn't group it, then the 13 may appear here. But since they are grouped, these items' horizontal positions are locked. So that by doing this, we can get a small reusable component. The blueprint of the selection grid looks like this. You can configure how many cells it is displaying. And the way for us to represent its selected state is to use the Boolean matrices of this large. And we are reading the matrix into the coroutine and yielding its list of coordinates to the user of the coroutine. And then we start to draw the GUI. We have clear button and the data panel. The clear button is just the button. The data panel is the rest of the GUI. And about the conversions of the between the Boolean matrix and the coordinate. If you are not familiar with NumPy, the Boolean matrix looks like this. And if you set some of its coordinates to true, you can use argvar to return you the coordinate that has true. So this function argvar converts the 2D bitmask back to the indices list. Exactly what we need. So to get a closer look to this GUI, what I want to do here is that these cells in the grid are selectable. These are just labels, not selectable. And this is the clear button. Next question, how to fill items in a grid. As we saw in previous examples, if you add 2 items, the second one will be created under the first one. So if you want to create a grid of items, one choice is to add items row by row with ImGUI simuli, which allows you to create the next button as the second item next to the your previous item. Or you can add items column by column using the columns API. The idea of columns API is that you can imagine that there's only one column by default in ImGUI because all the items are created one after each other. But with columns API, you are able to declare to say that there are multiple columns. Another choice to use is to use the DRIMGUI tables API, but currently it's not available in PyImGUI, the Python binding. So for this talk, let's play with columns API. So first difference is that you need to declare how many columns are here. So if you still remember, N is how many columns we can select, and this is the table head. Clear button. Very simple. Just if the button is pressed, the select sets the entire selected matrix to false. We'll make it auto hide later. And then the data panel. Here is where we are using the multiple column capability. Be aware when to get the next column. So for example, the first loop is working on the first column. It's calling the next column after the loop. So you are filling the row indices. And then the next, after calling next column, the next item you are adding is here. But the next loop, the second loop is different. It's calling a loop, which means we are adding items row-wise. Sorry, column-wise. Here's a demo. So far, very simple. So next thing to consider, how to make a selectable cell. This is an item in ImGUI called selectable. You can say that it receives the old selected state and returns you the new selected state after this frame. So after knowing that, we then can fill the grid column-wise in our second loop. So this entire thing is the second loop you saw previously. Previously, we only added the table title. But now, in an inner loop, we can add all the cells. Its label is the value to display, and its selected state before this frame is this, and we use that information to update its selected state. Here's a demo. So seems to be working fine. There are a couple of small issues. So first, this table head is not aligned with this because with the table content, because we are using columns API. Columns API is just adding elements down this row, down this column, down this column. There's no alignment. There's an easy way to solve it. The cause is that the button is bigger than a selectable item. So the quickest way to solve it is to replace a button with a small button. Small button is a button without frame padding. So it's as large as a selectable or text. The next issue is that the button doesn't auto hide. We can make it auto hide by saying, if anything is selected, we then ask whether we display the button and ask whether the button has been selected in this frame, etc. Otherwise, we just display nothing. Here's a quick demo. So seems to be working. The table head and body are aligned correctly, and the button is auto hiding. Is that it? Is that done? let's try to substitute some different data. So instead of asking the grid to display random data, we can ask it to display an I matrix and see what happens. Wait a second, it's not selecting anything. Well, that works. And the second one also works. But no, nothing else can be selected. What happened? So here's an unobvious knowledge of ImGUI. In dear ImGUI, items are with states have IDs. So text has no state, so text has no ID. The items that with the same ID share states. You need to, so if they are displayed by default, the ID is derived from the item's label. So you are using this, if you are using the same label for two items, you need some way to distinguish them. So in our case, I have only two kinds of labels in the previous example. First is 1.0, second is 0.0. That is why you are only able to select the first two cells. So a quick fix, in a label, the characters starting with sharp are hashed but not displayed. So we can use this to make the IDs unique. So in our example, instead of displaying a label using displaying in the selectables label directly using the value of the floating point, we can format it and add a hidden hashable content to the label. By the way, this is, of course, a very fancy language feature, and there's a proposal for C++ to add it. Now, it works. Okay. Before I go deeper, are there any questions? Okay, let's continue. I would like to spend some time talking about error handling. So in previous slides, we sometimes see code like this, begin, end. And if you are a C++ programmer, your intuition may be, why not using RARI? Well, we can certainly use it, for example, to save lines on the slides. But there are other things to consider. So let's take a look at this example. We are iterating over a scanned directory, iterating over it, and display some button. What if this line throws? Well, since we are not using RAI, the end group will not be called. So this widget is incomplete. You're going to receive an error. But should I really throw an exception at the first place? Can I throw an exception every frame? And also, if we do end that group or window or pop-up, what items we left on the screen? Do they respond to meaningful interactions? Last but not least, should I bring users' attention to the arrow? Here are some facts about ImGUI. So first, an ImGUI region cannot be reverted. The items in ImGUI are not like Qt widgets, which are objects. You can edit and remove them. No. In ImGUI, a region you started, then it cannot display on that frame. The added items cannot be deleted. And also you need to keep in mind that GUI must always be usable. It should not lose response. For example, you don't want to call a long-running function in one frame and causes the GUI to hang there. And GUI must follow users' expectation. Translation for that is unexpected things must become expected. Here's an example of how did I handle an error in ImGUI. This is a file explorer, and you can change directories by using those buttons. And if you are trying to access a directories that you don't have access, it's displaying an error. So you can see that I'm displaying an entirely different thing when I see an error, right? Because I think an ImGUI region should be atomic. It either works fully or not displayed at all. However, you can display something else. So the way, the approach I did in the example, which I'll be explained later, is that first, iterating over directory is, of course, processing data. If processing data can through, you should do it before entering the GUI region. And when you actually encounter an error and you want to bring users' attention to that error, you can substitute in different regions and provide meaningful ways to let users to act on. So in the file browser example, the normal UI layout looks like this. A window is a search input, navigation button, directory list, and selection list. When I encounter the arrow, instead of displaying this, I displayed only the navigation button and the arrow text. The implementation looks like this. So first, we process data outside the GUI region. And then if we encounter the arrow, we display arrow UI. Otherwise, we display normal UI. And finally, end the group. So far, any questions? Okay, if not, we can go back to our examples. How to model shared states. So let's try to create this pop-up, which have shared states. First, the pop-up is not a window. It's popped up if you do something. If you do something, for example, when clicking a button. I created a function that allows us to click a button and then open a widget in a pop-up. But this is boring part. This talk doesn't mean to teach you that. You can read this slide afterwards. Here's a quick demo about how to use it. Yeah, that widget is very simple. Just I copied from this sample code. Okay. So now I get how to use pop-up. Time to focus on creating a widget. First question, does this work? Can I model the states of two-channel volume using this? Remember that there's a link checkbox. So this doesn't quite work because if it is linked, then there's nothing to associate those two volumes from the different channels. Before talking about how to model the states here, let's first think about what does this, how to make a checkbox. So previously, we learned an item called selectable, which returns whether it has been pressed in this frame and allows you to update its selected state after the frame. A checkbox is not very different. Actually, pretty much the only difference is the name. It returns whether it has been clicked on this frame and its new checked state. So similarly, this is the checked state before this frame. Now it's time to think about how to model the states. We can think it in this way. If the two channels are unlinked, the volume of the channel can be deemed as accessing the volumes from an array. So in this case, the left channel is accessing vol 0, and the right channel is accessing vol 1. Right? This is unlinked. If linked, you want both to be accessing the same volume. In this case, we can simply say that if linked, the right channel is also using the value from vol 0. Now it becomes clear about how to model the relation between states. We can say that the right channel is the left-hand side, left channel is always using the vol 0, and the right channel by default is using vol 0 because it's linked. Otherwise, but this thing can be changed to true, and in this case, it's accessing vol 1. Now the blueprint of the widget becomes this. So in every frame, we start with yielding a pair of volumes back to the user of this coroutine. And then it's a grouped widget. We place the volume title, separator, and the components of the widget. Here we have the link toggle, the first checkbox, and the volume sliders, which shows the volume from the two channels, and then the final toggle, which is another checkbox. And the link toggle can look like this. It means to modify the download variable R, what the R channel should refer to. And if the checkbox is the checkbox in this frame start with saying whether the two channels are linked, and if it's clicked, we flip the state. Let's leave the mute toggle empty for now. We are going to deal with it later. Next thing to consider is that how to create the sliders. The sliders, you may notice that are created one next to each other. But as we previously learned, if you do that in ImGUI, you're going to receive a default layout that looks like this. And the trick is to use ImGUI seamline, which allows you to create the second items next to the previous one. The second thing we need to learn is how the sliders itself. This is a vertical slider. So previously, we learned a horizontal dragging. If you still remember, you put its old value here, and it updates its value and return it here. A vertical slider is very similar to that. You put the old value, this is the updated value. The only difference is that you must specify its width and height, because only the horizontal widget has a default width, just like a sentence displayed on the screen, but the vertical one doesn't. But it's a problem that is easy to solve. We can create a helper to use it. In this example, the helper returns updated value, and we put a width and height to it, which will be explained later. And because it's a volume slider, we set the min value to slide from 0 to 0 and max 100. And with the height can be calculated using ImGUI Calc text size. So this function, if you put a piece of text in it, it's returning, if we are rendering this text, what the width and height would be. This is width, height, and then I multiply the height by 10 so that I can receive a height of this thing. Given this, we are able to display the volume sliders. Very simple. We just display the label, same line, sliders, which updates its volume back to the corresponding channel it should be accessing. And then same line, another slider, same line, the R. Here's a demo. So you notice that even when I close the widget, it's still remembering, its volume. So looks good. Now let's add the mute state. So far we have sliders accessing their corresponding volume, the corresponding channels. And to add a mute state, one simple thought is to just add the state. If it is muted, we just say 0, 0. In that case, the mute toggle can be as simple as result state update. Here's a demo. Well, of course, the channels are not reacting to it, but it doesn't mean that this method is invalid. If you used Windows, that's exactly how the Windows volume switch works. But if you used YouTube, you may notice that at the time if it is on mute, if you press mute, then both channels drop to 0. And you can even manually press anywhere on the sliders. If it used to be muted, it then becomes unmuted. How do we do that? So we can think of it like this. If it is unmuted, nothing changes. The left channel is still accessing vol 0. But if it is muted, we can say that it is accessing a different array. We can say it's returning a value from vol inactive, and vol inactive is the values in vol inactive are 0 if it is muted. This requires us to swap in the vol array and vol inactive. Previously, our set of states looks like this. Now we add vol inactive. And because we are able to read 0 values out of vol at the right time, we don't need a if statement here. We can our code go back to the initial successful state before adding the mute button. So the next work is to swap those arrays. So previously, the mute checkbox is only updating the muted state. Here, if it is clicked, we can say swap those channels. But here comes a problem. That is, what if I manually, what if I press mute and then manually change the volumes in sliders? In that case, both volumes will have non-zero values, right? So we need to do something to fix it. Here, what I did is, if you modify the values in sliders, check whether the active one are equivalent to muted or not. If it is no longer muted, we set the inactive channel's volume to 0. Here's a demo. So yep, if I press muted, both channel goes back to 0. If I say it's no longer 0, then it appears that it's no longer muted. This is a special case. YouTube handles this nicely, but it's sort of out of scope for now, for this talk. And you can see that this muted button interacts correctly even with linked or unlinked. So far, any questions? Okay. Let's go to our last topic. So how to schedule work in ImGUI? And the ImGUI stands for immediate mode GUI, right? Everything everything that act on your actions happen immediately. So how to say that a change should happen a while later? Well, maybe you can use exactors, thread pools. or we can pull in by saying, on that frame, how much time has elapsed since your initial action. That works as well. But there's a much simpler way to deal with this. The idea is that ImGUI has a Planck time, which is the duration of a frame. The duration of a frame is 1 second divided by frame per second. In other words, you don't have to check for elapsed time. The elapsed time is elapsed n frames divided by FPS. So with this knowledge, we can build a timer. I don't have an example here, but I will talk about a related use case. But first, let's study a little more here. So how to do 2D graphics in ImGUI. We learned about ImGUI items. Can I draw anything else? The trick is to use a draw list. There are two kinds of draw list. First one is the window draw list, where the screen positions are relative to the current window. Or you can have get overlay draw list, where the screen positions are relative to your entire Un-Gui application. And the member function of draw lists are just very simple 2D graphics methods: add line, add rectangle, circle, text, image, field or unfilled. So the goal here is to create animation in ImGUI. What is an animation? If you refresh fast enough, anything can be an animation. It's just a matter of what to draw and when, right? If you at when you can decide to draw or not to draw, then you have an animation. Here's an example. So it's a part of a matrix application we created. I searched for a cell, a non-zero cell, and you saw that the animation is, let me play that up again. Flashing. And the way I did it is very simple. First, in this frame, we compute the current FPS, and then the elapsed time is a counter. The counter remembers how many frames we passed since I pressed the search button. And this statement says, for every first half second, for the half second of the every 0.7 second, if the frame drops in that region, we drop water. Otherwise, we don't decide what to draw and when. And then finally, if our elapsed time goes over 2 seconds, we just reset the counter. So to summarize this talk, ImGUI exposes states rather than events. And ImGUI is suitable for GUI that follows data. And in those examples, you may already notice that design ImGUI is roughly same as design data structures. You can use the relation between data structures to model shared states. And finally, have fun. Questions? Can you call, so first question, can you call ImGUI functions from threads other than the main thread? I'm not sure. You may need to synchronize it. I haven't tried. I only need to call ImGUI functions from the main thread. But in my application, I do have an thread pool running behind to do heavy works for like computation-related works. Oh, so the question is, would you recap the pound trick with labeling? So that part is that in ImGUI, the items with the same label, if both items have states, those items are deemed as items with associated states. So we need to distinguish them to make their ID different. The ID is computed from their labels. But if they have the same label, you cannot distinguish them, right? Here, the hash trick is that ImGUI will display the label until the hash. Anything comes after the string comes after the hash are not a part of the label to display, but they are part of the ID. So we can add some different things to after the pound to distinguish their IDs. This is just a quick trick. The IDs in ImGUI are managed hierarchically. You can also use push ID and pop ID to manage the ID stack. You can read their FAQ to learn more. Why didn't the 00 select together? Yeah, because all of those are selectable cells. And then initially, my program displayed labels directly, and those labels are all 0.0, right? And to ImGUI, they are items that share states. Because they have same label, so they have the same ID, so they share states. So that is why the 0.0 are select. Oh, what? Oh, sorry. The question is, why didn't those 0.0 select together? Well, you can imagine that they should because they share states, right? But the problem is those 00 appears at different grid and they have their selected states stored as a matrix, right? In my example. So presumably, if they really share states, they should select together. But the problem is that I also manage the state outside ImGUI item tree. So at the first time it's selected, it's immediately unselected because the first two cells are always false. So they becomes popped, becomes immediately unselected. So that is why they didn't select together. Yeah, that's a tricky question. Any other questions? Okay, if not, let's end the talk. Thank you for coming to my talk.